Okay, finite math, section 2-1. Systems of linear equations with unique solutions is the title. What we get into today is, I showed you a variety of methods in chapter 1 on solving systems of equations. We use the y equals method, we use graphing, we use substitution, and we use linear combinations. Each one has an advantage at times over the others, and the trick is knowing which ones to use. Now, everything I've shown you so far involved a 2 by 2 system. That means two equations with two unknowns. So what happens when we work with something more difficult or higher order systems, like a 3 by 3, a 4 by 4, or even bigger than that? Okay, so to do this, we develop the concept of matrices and use them to solve difficult systems of equations. So first of all, what is a matrix? A matrix is simply a rectangular array of numbers. I'm going to address that shortly with several examples, so that will be easy for you to find. And then here's the big thing, the Gauss-Jordan elimination method. Everything we do in this section gets us that. And I usually call it Gaussian eliminations. Most of the older books call it that. But basically what it is, it's a step-by-step method used to solve higher order systems of equations. This process involves first writing the equations in matrix form. Then by using our row operations, we put the matrix in diagonal form. And once it's in diagonal form, then we can simply read our answers off. Now that sounds like a lot, but I'm going to break it down into some smaller sections, so hopefully you can get there. So first of all, let's talk about taking systems of equations and rewriting those in matrix form. This is easy. I have the equation here, x plus 2y equals 3. So we know there's a 1 there. We don't write it down, but we know there's a 1. So I'm simply going to take 1, 2, and 3. 1, 2, and 3. And then underneath that, I've got a -5 and a 4 and a 1. That's matrix form. That's all there is to it. Now, what you need to see on this, if it is a matrix, then it's rectangular, meaning it's in rows and it's columns. This would be a 2 by 3 matrix. 2 rows, 3 columns. It's very important to keep everything lined up. As we go on, we're actually going to be doing operations, and if you don't get things where they're supposed to, then it gets messy. Let's look at the second one I have here. I've got x minus 6y equals 4, so that's 1x minus 6y equals 4. And on the bottom, I've got 4x, so I put a 4, plus 3y, so I put a 3, and I got 7 on the other side. And that will be our matrix. Okay, here's a 3 by 3. So I got a 1, a 2, a 1, and I finished with an 18. So as it works out, basically you've got an X column, a Y column, and a Z column. The X coefficient, the Y coefficient, the Z coefficient. Second row is going to be 2, -1, 3, and 7. And on the bottom you got 4, 1, -1, and 6. And my last one. As you can see, this is starting to become easy. 3, -7, 1, 5. Second row, I've got a 4x. Notice there's no y's. So that's 0 y, so I'm going to put a 0 here. I've got 1 z, and then I got a 10. And then on this one, there's no x's, so I got 0x. I got 2y, there's no z's, so I'll put a 0 and then a 6. Essentially what happens when you put it in matrix form, you eliminate all the variables, you eliminate the equal signs, and you eliminate the plus signs. I will throw one more thing is, some books, I think this one's this way, every once in a while they'll put a line here. I never do, but if you see that, don't let that confuse you. Okay, so that's putting a system into matrix form. So now let's talk about diagonal form. Diagonal form means we're going to try to take each of the matrices and we're going to rework them, and there's rules that you follow. I'm going to go over the rules in a second, but we want to get it into a form like this. You have to have a 1 in each location on the main diagonal of the matrix. Let's jump down here. Here's a 2 by 2. The main diagonal is right there. In a 3 by 3, there's the main diagonal. So I have a 1 on each of the positions in the main diagonal. That's what this one says. And then except in the last column, everything else is zeros. So if you look at the main part here, you got zeros. You can see all the zeros here. And then the last column, I've got double question marks, but here and here, this will end up being your answers. So when you get down to it, what was it? That was 1x plus 0y, or just x equals, that will be your answer. This will be y equals. When you come down here, there's x equals whatever that is. Here's y, and there's z. So it'll be real easy to figure out what your answer is once you get it into that form. Okay, now what? Well, now we're going to talk about row operations. It's like a game, and you got to know what the rules to the game are. So it will tell you you have 3 things that you can do. First of all, you can multiply any row by a non-zero constant. Okay, so as long as it's not 0, you just multiply by some other number. That's what a constant means. Number 2, you can interchange any 2 rows, switch them. And number 3, you can multiply any row by a non-zero constant and add it to a second row, replacing the second row. Okay, now that's a lot of words, but once you see it put into place, it'll make sense. Here's an example of the first one. You can replace any row by a non-zero constant of itself. That means you're going to multiply any row by a non-zero constant. Now, notice out here, these are called the instructions. This is telling you what we're going to do. This says take 3 times whatever row 1 is. So when you look at it, here's row 1, there's row 2. So we're simply going to take 3 times each of those. So 3 times 1 is 3, 3 times 2 is 6, and 3 times 5 is 15. Bottom row, we're not doing anything in it. It stays the same. So that's one of my row operators. I could take any row and multiply it by a non-zero number. Number 2, I can interchange any 2 rows. Notice my instruction here, I've got a double arrow. That means we're going to take row 1 and row 2, and we're basically just going to switch them. So the 1, 2, 5 that's in row 1 now become the second row. And the second row becomes the top one. Now you're going to ask, why are we doing these? Well, we're going to use these to try to get everything into diagonal form. And I got more examples. I'll show you how we're going to do it. Okay, and then the third one says replace any row by the sum of that row and a constant multiple of the third one. And I got it worded different, but you can multiply any row by a non-zero constant and add it to another row. So this one says we're going to take 2 times row 1 and add it to row 2. So row 1 stays the same. I'm not doing anything with it. And you'll notice when I put my instructions, and you're going to have to do this when you work your problems, you're expected to put the instructions out front. That tells me what you did. So this says take 2 times row 1. So I'm going to take 2 times 1. We'll write it down here. I'm going to take 2 times 1. I'm going to add it to 7. This number is going to be a 9. And you do it all the way across. We got to take 2 times the 2 and add it to the number right below it, which is 4. So 2 times 2 is 4, plus 4 is going to be 8. And then the last one, we're going to take 2 times 5 plus 8. So that's going to be 10 plus 8, 18. So that's an example of your row operations. You're going to need to know those. Okay, now what? Okay, so now I'm going to do a couple examples using Gaussian elimination. So my equations, I've got 2x minus 6y equals negative 8. So my first step, I'm going to write that as a matrix. So 2, negative 6, negative 8. And the second row is going to be negative 5, 13, and 1. Now, eventually, we want to get down to our diagonal form, and we want to get a 1 here. Okay, so here's the easiest way of getting a 1. Now, you're going to notice I offset this a little bit. This is my second matrix. I want to get a 1 here, and to get a 1, you're going to multiply by the reciprocal. So that's 1/2 times row 1. And you put a little arrow, and everything's lined up with row 1. So 1/2 times 2 is 1. 1/2 times negative 6 is negative 3. And 1/2 times negative 8 is negative 4. And the bottom row stays the same. So eventually, when I get down to the bottom, I'm going to have a 1, a 0, a 0, a 1, and then I'm going to have 2 numbers over there. So far, I've got that one taken care of. I got the 1 right here. Okay, now you might make a little notation. There's 2 main things as you work through these. Once you get your Gaussian going. We got a 1. Okay, here's what I want you to write down. Put it someplace off to the side. To get a 1, multiply by the reciprocal. To get a 1, you multiply by the reciprocal. So we wanted to change that 2 into a 1. The reciprocal of 2 is a 1/2. So we took 1/2 times that row, and we got the 1. And anytime you get a 1, that is called the pivot. We'll talk more about that later on. Pivot. It's a T. Now, the reason we got a 1, I know we want our end result to be that, but now that we have the 1 here, I'm not going to change row 1, I'm going to change row 2. Now I want to get a 0. So I got a 1, I'm going to get a 0. To get a 0, write this down off to the side. This is important for you. To get a 0, multiply and add. Multiply and add. When you go back to I'm going back to the other page here, you can multiply and add. So that would be your third step here. To get the 1 to begin with, I multiply by the reciprocal. To get a 0, we multiply and add. So you can use those. So now we got to think a little bit. We want to get a 0 here. We're going to multiply something times 1, add it to negative 5, and get a 0 here. So the magic number is going to be 5. I'm going to take 5 times row 1, and I'm going to add it to row 2, and put all my answers right there. And notice how this is lined up with row 2. So 5 times 1 is 5, plus negative 5 is 0. We knew that. And we got to go all the way down. So 5 times negative 3 is negative 15. Negative 15 plus 13 is negative 2. And the last column, you got 5 times negative 4 is negative 20. Negative 20 plus positive 1 is negative 19. So at this point, if you go down to the bottom, I got the 1 and I've got the 0. So I'm really about halfway done with the problem. Okay, next step. I got a 1, I got a 0. Now I want to get a 1 here. Remember, to get a 1, you multiply by the reciprocal. So the reciprocal of -2 is -1/2. So I'm going to take -1/2 times row 2. Row 1 stays the same. I'm not doing anything to that row. So -1/2 times 0 is 0. -1/2 times -2 is 1. Anytime you get a 1 like that, that becomes your pivot and you circle it. And then -1/2 times -19, the negatives drop out. That ends up being 19/2. Okay, one last step. Because I've got the 1, the 0, and I got the 1. The only thing left, I got to get a 0 where the -3 is. So on this one, I'm not going to change the bottom row, so it stays the same. Matter of fact, if you're pretty smart, you realize y is going to be 19/2. To get a 0, what did I say? Multiply and add. So the magic number here is going to be 3. I'm going to take 3 times row 2 and add it to row 1 and put my answers in row 1. 3 times 0 is 0, plus 1 is 1. You'll notice once you get 1s and 0s, they don't change. 3 times 1 is 3. 3 plus -3 is 0. And 3 times, I'm going to put off the side here. I'm going to have 3 times 19/2 plus -4. I took 3 times this number, and I got to add it to that number. So that's 3 times 19/2 plus -4. Okay, so that's going to be 3 times 19. Everybody knows that's 57/2. Plus, now we're going to run into a problem because we're going to have to, we got some fractions. When you add fractions, you have a common denominator. So that means I'm going to need to write this as something over 2. That's going to be -8/2. 57 plus -8 is 49. So 49/2. And that's the number I'm going to put right here. Notice how this is in diagonal form. You got 1s on the diagonal. You got 0s every place else. So your answer is x is going to be 49/2. And y is going to be 19/2. And that's how you do it. Now, that probably looks like a foreign language to you right now, but you'll get good at it because we're going to do a lot of these as we go on. Okay. So let's do another one. Of course, this will be a little bit tougher. Okay, so first thing you got to do is put it into matrix form. So I've got 3, -6, 9, 0, 4, -6, 8, -4, -2, -1, 1, 7. One thing I didn't mention earlier, but when you write these matrices, you always put brackets around it. And you'll notice when I type things out, they're not squared out, they're more rounded. Let me see if I can pull one of those up. So going back on this one, see how they're more rounded off? That's just because I got to type it that way. They're supposed to be squared off. It should look more like that when you put them in. Now, it's important that you kind of follow our directions here on how to do things, because when you do homework, when you turn things into me, I look for certain things. And it's important for you to be neat and organized and show me what you need to show. So I'm going to great lengths here to make sure you see everything. Okay, so let's get started. First thing you want to do when we get a 1 where the 3 is. How do you get a 1? You multiply by the reciprocal. The reciprocal of 3 is 1 over 3. So 1 over 3 times row 1, put the answers in row 1. So 1/3 of 3 is 1. That's going to be my pivot, so I'm going to circle it. Anytime you get a 1 that way, that becomes your pivot. You'll only have one pivot as you go along. 1/3 of -6 is -2. 1/3 of 9 is 3. 1/3 of 0 is 0. And row 1 is done, and then we're not doing anything to the other ones. And for the most part, you do one row at a time. There's certain places where you can combine, and I'm going to show you one because here's a step right here. So eventually, remember, we want to get 1s on the diagonal, and we want 0s every place else. So the next step is to get a 0 where the 4 is. Top row is going to stay the same, and it will stay the same for a while. The second row, to get a 0 where the 4 is, we got to multiply by -4. So you multiply by the opposite and add. So that's -4 times row 1 plus row 2. By the way, I got row 2 right here. The second part here, whatever's after the plus sign, that's the row you're going to. This one right here is wherever the pivot row is. The pivot row is where the pivot's at. So that would be row 1 in this case. Okay, so -4 times 1 is -4 plus +4 is 0. -4 times -2 is 8. 8 plus -6 is 2. -4 times 3 is -12. -12 plus 8 is -4. And -4 times 0 is 0 plus -4 is -4. Okay, now the next step would be to get a 0 here. Now, I said a second ago, basically you do one row at a time. Well, if you're getting 0s, you can do, in this case, 2 at a time. So to get a 0 where the -2 is, I'm still using the 1 up here. So now the magic number is 2. So I'm going to take 2 times row 1, because that's your pivot row, plus, and then I'm putting my answers in row 3. I'm replacing row 3 with that. So notice how it's all lined up here, and that's where I'm going, row 3. So 2 times 1 is 2, plus -2 is 0. 2 times -2 is -4, plus -1 is -5. 2 times 3 is 6, plus 1 is 7. And 2 times 0 is 0, plus 7 is 7. Okay, we have just finished what they call an iteration where we got a 1 and 2 zeros. That's kind of like the first cycle. We got the first column done. Now we're going to start working on the second column. Now, in this column, which one do you want to get? Well, we want to get a 1, and if you'll remember, we want 1s on the diagonal. So this place right here where the 2 is, we want to make that into a 1. Top row is going to stay the same. So to get a 1 here, we're going to multiply by the reciprocal, which is 1/2. So we're simply going to take 1/2 times row 2. So half of 0 is 0. Half of 2 is 1. That becomes my new pivot. So I had 1 for the first column. This becomes my pivot for the second column. Half of -4 is -2. Half of -4 is -2. Okay, bottom row stays the same. I'm not changing that. Okay, moving on. Now that I have the 1, I want to get zeros above and below. So to get a 0 where the negative 2 is, I'm going to use that 1 to get a 0. So you multiply by the opposite. The opposite of that's 2. So we're going to take 2 times row. Now my pivot row is row 2 this time. And I'm going to replace row 1. 2 times 0 is 0 plus 1 is 1. Remember I said those won't change. 2 times 1 is 2 plus negative 2 is 0. 2 times negative 2 is negative 4. Negative 4 plus 3 is negative 1. And then 2 times negative 2 is negative 4 plus 0 is negative 4. Second row stays the same. And now I want to get a 0 where the negative 5 is, using that pivot. So the magic number now is positive 5. You multiply by the opposite and add. So the opposite of negative 5 is positive 5. So 5 times my pivot row right now is row 2. And I'm going to replace row 3. 5 times 0 is 0 plus 0 is 0. 5 times 1 is 5 plus negative 5 is 0. 5 times negative 2 is negative 10. Negative 10 plus 7 is negative 3. 5 times negative 2 is negative 10 plus 7 again is negative 3. So you'll notice the first two columns are exactly what I want. It's all ones and zeros. I started about by getting the first column where I wanted. Let's do this. I'm done with that. So the first column, I got ones and zeros. Now, when I get down to here, my first two columns are ones and zeros. Now I'm going to start working on the third column. What do you do first? Well, you got to get a 1. In this column, where do you want a 1? Well, remember it's on the diagonal. So the negative 3, I want that to become 1. Top row stays the same. Second row stays the same. Okay, and to get a 1 where the negative 3 is, I'm going to multiply by the reciprocal. So the reciprocal of negative 3 is negative 1/3 times row 3. So negative 1/3 times 0 is 0 because you got to multiply times the whole row. Negative 1/3 times 0 is 0. Negative 1/3 times negative 3 is 1. And negative 1/3 times negative 3 is 1. And this becomes my new pivot. So when you go up here, that 1 way back up here became, that was my pivot originally, actually here. There's your second pivot. Now you got the third pivot. Got one more step. The bottom row's done. It's in row reduced form. Matter of fact, at this point here, you know that Z is going to be 1. Okay, we want to get a 0 here using that pivot. So the magic number is going to be 2. I'm going to take 2 times row 3, because that's the pivot row, and I'm replacing row 2. So 2 times 0 is 0, plus 0 is still 0. 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus negative 2 is 0. And 2 times 1 is 2. 2 plus negative 2 is 0. Now you know y is equal to 0. And then to get a 0 where the negative 1 is, all I have to do is take row 3 plus row 1. Because, I mean, if you just look at it, 1 plus negative 1 gives you 0. Okay, let's go down the line. So 1 plus 0 is 0. 0 plus 0 is 0. 1 plus negative 1. I'm sorry. I don't know why I put a 0. That's supposed to be a 1 there. Just miscopied. 1 plus negative 1 is 0 here. And then 1 plus negative 4 is negative 3. So at this point, x is negative 3, y is 0, and z is equal to 1. And many times we write this as an ordered triple, negative 3, 0, and 1. You know, in the other one we had an ordered pair. Now we've got an ordered triple. So back, this is the previous example when I got it down to here. That was an ordered pair because you have two of them. But now with three variables, that becomes an ordered triple. Okay, good job so far. I know this is confusing, and until you've worked some of these, it probably won't make sense. Okay, so now we're ready for the example 3. This is actually example 1 if you're reading the book, but I want to give you a little bit more background before we got into it. And there's more examples in the book if you want to look those. And if you don't have the book, there's still the ebook that you can get off of My Math Lab if you want to do that. Okay, so we got a problem here. This is what we want to get to, is being able to solve something like this. So it says the Upside Down Company specializes in making down jackets, ski vests, and comforters. The requirements for down and labor and the profits earned are given in the following chart. So to make a jacket, you need 3 pounds of down and 2 labor hours to do it. That means 2 hours of labor. And your profit is 6. For a vest, it's 2 pounds, 1 hour, and $6. And for a comforter, it's 4, 1, and 2. So basically, I'm going to let X represent the number of pounds of down, Y the time, and Z is going to be the profit. Now, there's more to the problem. Each week, the company has available 600 pounds of down. So if this is my down column, I'm limited to 600. And it says 275 labor hours, so that is limited to 275. And then I want a profit. When I add all this stuff up, I want 1150. Now, when you look at what I've got here, you're going to say, well, 3 plus 2 plus 4 does not equal that. No, but it takes 3 pounds for each jacket, and I've got X. See what I say? Oh, I'm sorry, I had those backwards. So if I got X jackets, I'm going to have 3X of these. I'm sorry, I got my variables in the wrong place. They did this backwards from what I usually do. My fault. Okay, I'm going to have 2Y of these and 4Z of those. And just like here, I've got an X, a Y, and a Z, and an X, a Y, and a Z. Okay, so we define our variables, and then we want our equations. So the equations are going to be this. You can see it right here. You're going to have 3X plus 2Y plus 4Z equals 600. And then for the time, I'm going to have 2X plus Y plus Z equals 275. And from the profit, I'm going to have 6X plus 6Y plus 2Z equals 1150. So I define the variables. I now have my equations. And now we want to write that as a matrix. Okay, let me go to the page here. So if I want to write a matrix, I'm going to have 3, 2, 4, 600. Second row is going to be 2, 1, 1, 2, 7, 5. And 6, 6, 2, and 1150. Okay, now we want to solve it. Okay, that's the third step, or the last step. I want to solve using Gaussian elimination. So let's just get rid of that page. So we've got it in matrix form. Let's solve it. Okay. Now it's going to get a little bit harder. Okay. You have to decide, how do you get a 1 here? And from what I've told you, we're going to multiply through by the reciprocal. So we're going to take 1/3 of row 1. 1/3 of 3 is 1. 1/3 of 2 is 2/3. 1/3 of 4 is 4/3. And 1/3 of 600 is 200. Now I know as I go through these, I can look at them, probably write down the numbers. With practice, you'll do them as quick as me. 2, 1, 1, 2, 7, 5. That doesn't change. And the last one is 6, 6, 2, 1, 1, 5, 0. Okay, last two rows didn't change. Okay. Now that I got a 1 here, that will stay the same. So all I'm doing is copying the numbers. It does get a little tedious. So I get tired of recopying the numbers. But remember, this is like a shorthand way of writing equations. You're not writing the x's, the y's, the z's, the equals, or the pluses. Now, to get a 0 here, we're going to take -2 times row 1. We're going to add it to row 2. So -2 times 1 is -2, plus +2 is 0. Okay, -2 times 2/3 is -4/3. -4/3, think of that as 3/3. That becomes -1/3. -2 times 4/3. And let me interrupt myself. You may want to do it like this. Just go off to the side. I'm taking this -2 times that 4/3, and I'm adding to the number below it, which is 1. I'm sorry. -2 times the 4/3 plus the 1. So that's -8/3 plus, think of this as 3/3 because you need a common denominator. And when you add those, that's going to be -5/3. So just go off to the side somewhere and do that. I can do a lot of stuff in my head. You may not be able to. You do what you need to do. Okay, so -2 times 200 is -400, plus 275 is going to be -125. Now we go to the bottom row. To get a 0 here, I'm going to take -6 times row 1 plus row 3. So -6 times 1 is -6 plus +6 is 0. -6 times 2/3, that's going to be -4 plus 6 is 2. -6 times 4/3, that's going to be -8 plus 2 is -6. Now I know I'm doing this in my head. If you have trouble, just go off to the side, do it yourself. I'm just trying to keep things going. -6 times 200 is -1200, plus 1150 is going to be -50. Okay. So I got the 1, I got 2 zeros. Now we're going to go to the second column. Where do you want the 1? Because you're going to get a 1, then you're going to get 2 zeros. I want a 1 where the -1/3 is. Okay, top row stays the same. All I'm doing is copying the numbers. The second row, I want to get a 1 here, so we're going to multiply by the reciprocal. The reciprocal is -3. So -3 times row 2. So -3 times 0 is 0. -3 times -1/3 is 1. That becomes my new pivot, so I'm going to circle it. -3 times -5/3. The negatives drop out, the 3's drop out. That's going to be 5. And -3 times -125 is +375. And the bottom row stays the same. So as you go through, you get a 1, you get 2 zeros. That's what I did here. I got a 1, I got 2 zeros. Now I'm going to get a 1, now I'm going to get 2 zeros. So I got to get a 0 where the 2/3 is. So I'm going to multiply negative 2/3, that's the opposite, times row 2, and add it to row 1. Negative 2/3 times 0 is 0, plus 1 is 1. Negative 2/3 times 1 is negative 2/3, plus positive 2/3 is 0. Negative 2/3 times 5, that's negative 10/3. Negative 10/3 plus 4/3 is negative 6/3. This ends up being negative 2. Okay, and then negative 2/3 times 375 is negative 250. Negative 250 and positive 200 is negative 50. Second row stays the same because that's where the 1 was. Now I want to get a 0 where the 2 is using the 1, so I'm going to take negative 2 times row 2 plus row 3. Put the answers in row 3. So 0 and 0 is going to be 0, and negative 2 times 1 is negative 2, plus positive 2 is 0. Negative 2 times 5 is negative 10. Negative 10 plus negative 6 is negative 16. Okay, and then we're going to have negative 2 times 275. Let's do this. So it becomes negative 2 times 375. Well, that's 750. Negative 750. Negative 750 and negative 50 become negative 800. First column's done, second column's done. Now I want to get a 1 where the negative 16 is, because the 1s are always on the diagonal. To get a 1, you multiply by the reciprocal. Top row stays the same. Second row stays the same. And the third row, the reciprocal of negative 16 is negative 1 over 16. Times row 3, put our answers in row 3. So 0 and 0 will stay here. When you multiply times 0, it's the same. Negative 1 over 16 times negative 16 is 1. That becomes my new pivot. And negative 1 over 16 times negative 1 over 800, believe it or not, is a positive 150. Numbers are getting a little better. Matter of fact, at this point, Z is going to be 50. Okay, one more step.